sure we'll have a few more people come in afterwards because we had lunch, and I'm sure some of those other sessions went long. But thank you for being here. I will tell you, I'm doing 3 presentations here at K-Scope, and this one is actually one of my favorite ones. So who in here is a statistics person, likes it, or just feels they might need this might be a good refresher for? Yeah, thank you. So I'm actually one of those weird people that I actually have a degree in information systems and in statistics. So I learned the statistical side of data for this kind of thing back in the early 2000s, and then I was told when I graduated, forget it, it's never going to be used again. And then about 2 or 3 years ago, people went, this is brand new, and I said, no, it's not. So when data visualization was introduced, I was working for Oracle at the time, and I was told, hey, you have 6 months before you give your first presentation, so dig in and become the expert. So I went into the back and I figured it all out, and I was like, this is actually kind of fun. And so then this year, I kind of focused on some of the advanced analytics items and realized that a lot of people, even the sales engineers and Oracle people, were using the advanced analytics but without understanding what it actually means. And so I took it upon myself to actually finally put it together, because even though the advanced analytics pieces are actually really nice and they're very helpful, if you don't use them the right way, it can give you the wrong information. So hopefully understanding some of we're going into the statistics behind it, but I'm not going to give you like Mahabalas's formula. We're just going to talk about it and we're going to skip over it. So hopefully this won't be too much, but so let's get started. By the way, my name is Sarah Zumbrum. I'm the Vice President of BI and Analytics for Axalytics. My website is RealTryGeek, and you can find me on Twitter at TryGeekSCZ, and this man and I go back and forth quite a bit. So we'll be all right. So a little bit about today. I don't want to scare you away, but I have 71 slides, only because if I tried to do this in demo mode, it would be very hard to follow, so I want to do this. But the last little bit I'm going to actually spend in the demo mode so you can actually see what it looks like and do some comparisons. But please don't be afraid that there's so many slides. It's just to help you understand. And also, you can download these slides later and put them in your pocket and take them home. So we're going to give you a little bit about me, even though I've already told you some. But then we're really going to get into what are the core capabilities of data visualization? How is it built? Like, honestly, how is it built? Like a house. Then we're going to go into the 5 advanced analytics options. Talk a little bit about machine learning, because that is a newer piece of this puzzle, and some of the really neat things that you can do with that. And then I'm going to show real quick how you get import scripts and visualizations, and then we'll do an actual demo. So a little bit about me. Like I said, I'm a vice president. I'm currently on an independent Oracle user group board of directors, formerly on the ODTUG board of directors, and before it was the EPM community, we had a Hyperion special interest group, and I was on there. So I've been around ODTUG for a long, long time, and I have a lot of respect for it. I'm an ACE alumni. I was a director in the BI group, and then, like I said, author of the blog where it talks about everything from data visualization, data science in regards to Oracle, and then also the analytics cloud. And my previous life was Essbase, so there's some stuff from there back in going back to like 2013, 2014, something like that. So real quick about my company, we are an Oracle partner. We kind of do everything from EPM to BI and everything in between. We're based all over the United States. So we've done it. I worked for Oracle in the public sector group, so we do everything from public sector to commercial and everything in between. 100% of the consultants are certified, so that's a big thing for us. So enough about that. Let's go into the details and talk about what are the data visualization's core capabilities. So I apologize if this picture is kind of grainy, but all I want to do right now on this slide, for the data set that I'm going to be using today, I want to tell you a little bit about it. I try to find something that's relatable and sports related. But I took all the winners of all the summer Olympic events since 1896 and kind of put them into this data set that you see on the right side. But basically here are the data pieces. So as we're going through this, everything is going to be related to this data set because it's easier for everybody to understand. So some of the basic capabilities have to do around data visualizations. Otherwise, it wouldn't be called that, right? So you have your kind of basic ones here. So right now, we're just looking at the sum of metals by year, by gender. So, I mean, this is going to be your basic bar chart. Nothing fancy, but it is a lot nicer than trying to build it in Excel, if you will, especially when you have like 31,000 lines. Now, I wanted to highlight here because we have a space called My Calculations. So it's actually a custom calculation that I made and then used in the graph. So these are, and it's very simple to use. You can either type in the data element item names, or you can just drag and drop them. So if you've used any kind of Oracle like BI, database, et cetera, all those calculation options are available for you to use. So you're not limited to whatever. And also, does anybody use R or have used R, will be using R? Know how to spell R? Just kidding. You can actually bring in your own R scripts too to use. So that's just a little bit of tidbit information that if your company is using some of those, you can actually import them in as well. Data mashups, who's heard of this so far? Okay, so just about a quarter of the people. So what data mashups are is where you're able to take two sources, and these sources could be a database, it could be Excel spreadsheet, it could be SQL Server, it could be anything, but you can mash up as many elements as you want. There was somebody on my team that did 40 and decided they got bored because it kept working. And if there are like column names, the system will go ahead and join those together. However, you can go in and change them, which is what I had to do here, because I wanted to get the actual country details, like maybe what the population was, and pair it up with the actual data. So here, the code and the country were the same, so now those are joined together for me as well. So this is just some really nice, and I'd like to think of, like if you have somebody who's in finance and you have your one system of record, your GL, but maybe they have something in a spreadsheet, like every finance person does, but they want to mash it up together, they can do it right here. Mapping is actually built in. It's a core capability. So anybody who has used BI knows that you kind of have to go and set up the maps and all that. It's already done for you. It's already taken care of, so you don't have to worry about doing that yourself. And then your end users who may not be technical, there's no additional work for them to do. And then now we get into the advanced analytics. These are core capabilities. Now you do have to run a script to install them, but that's not, I mean, it's literally just clicking a button and it runs. But the core capabilities are highlighting, so you have the clusters and outliers, and then you have reference lines, trend lines, and forecasts. This is where we're spending most of today. We're going to deep dive into those. And then machine learning, and that's kind of a buzzword right now, right? But that capability is built in, and it's called explain. So if you choose an attribute and you right-click on it and it says explain, what it does, it goes through a series of algorithms, and, well, that's what they are, to kind of figure out, you know, what are the basic facts about discipline, what are drivers, segments, et cetera, what are anomalies, so that you don't have to go and pick these out. And so we'll go to this a little bit later, where this can be very useful, and you don't have to do a thing. You just have to sit and go get a cup of coffee while it runs for you. And then also, Oracle, there's a link, and I'll have it later, where you can actually download other visualizations. You can download R scripts. You can download calculations for free. And this is, Oracle puts some of these up here, or some of Oracle's partners put some things up here. And this is really cool if you want to have, so like say if you're from India, and I don't think Oracle out of the box here has like the different regions and all that within India, but you can actually download one here and load it up. Likewise, if you have your own maps, like maybe you have your company floor, and you want to be able to bring in a map of your building, you can do that. You can import that in. Also, if you have any custom visualizations or scripts that you have from R, like I mentioned earlier, you can bring those in as well. So how is data visualization built? It does all that stuff, but how is it built? And so this where it starts to get geeky, so I hope you guys enjoyed the geek stuff. Basically, all data visualization is a Java program built on R. That's really about all it is. And it has some level ups that allow for, so we're going to look at R later, but with R, you can see the visualization, but you can't actually like interact with it. You can't hover over it, get the details. So it allows a level up, if you will, of the visualization. You can do a little bit more with it. It adds spatial without doing anything special. And then also for the advanced analytics, you aren't limited to just R, that's just my background, but it also has Python. So if you work with Python, maybe more than R, you can still bring those in and use them just fine. So that's the basic concept of how it's built. You have something to interact with the data and then a level up above. So as I was saying just before, so and if anybody's worked with R Studio, anybody? Here's the actual code that I wrote here to build out a graph of the men versus women. So this is in traditional R, traditional visualization, whereas the bottom right shows what it looks like in data visualization. It looks a lot better, right? And you have no code, which is always even better, especially for the end users. And so, and I like this one because I decided to write a code to write a grouping of all gold winners by gender and color by country. Well, let me tell you this, you can't really differentiate between the colors very much, but that's what it looks like in R Studio. However, in data visualization, it gives you a nice stacked graph that you can actually hover over and actually see the details behind each of those bars. But you can still see they're definitely one and the same. It's just presented with a little bit of steroids, if you will. So how does the spatial portion work? Like, how do you always know? So if we have the United States tomorrow, we have a 51st state, probably in about a week, it'll be recognized. But how? Well, if you go into the guts of the program, you'll find that all the map items go to this place called elocation.oracle.com. And as you can see, you can go there yourself just fine. There's no problem. And this looks like a very boring old Oracle site because it's only meant to be accessed by the guts of programs, right? And this is no different than going to it from BI or a database or anything else. They go to the same location because Oracle uses this as a repository to access. They only have one place you need to access, update any of the map, spatial map data, etc. So all your map stuff comes from live online. So the very first time you create a map and you're not connected online, it's going to fail. So the very first time you create a map, you need to be connected so they can go say, okay, here are the data points I need, let's shove it back. But after that, if you already have your map in that data, it'll work just fine. So when it fails the first time, go, am I connected to the internet? And even coming down, so like one of the ways that I said that you could upload custom maps, it's through GeoJSON files, and it's just a geocoder, so that your geocodes are actually going through this site to render correctly. So the advanced analytics portion, there's the machine learning side, and there's also the R side. So for the, this one is focusing on the machine learning, because on the R side, it's really just a script and it's downloading packages local to your machine. And that's just done when the installation is done. However, for the machine learning, because this is brand spanking new with Oracle, something they're really trying to push out, if you go to this site that comes up, because if you watch the lines when you're installing it, it says oss.oracle.com, DVML, Data Visualization Machine Learning. And so if it goes to that site, it comes to here, and you're like, yep, still boring. Well, it's not meant for you. It's meant for the machine, because it actually downloads either a package or a zip, depending on if you have a Mac or a Windows machine. So then that runs behind. So if you download the R Analytics, that's going to run in about 30 seconds. This is probably going to take about 2 or 3 minutes. That's because it's downloaded in a huge package. And so is anybody using data visualization currently right now? So you have to, every time you upgrade, you have to re-download, right? This is why, because you're getting the new guts. That's why you have to re-download it every time. But if you take off the DVML and you come over here to the OSS, you find out that it's Oracle's open source projects. So even the machine learning items are actually considered an open source project. So it's secret, but it's not secret. Sometimes you just have to follow the breadcrumbs that are right in front of your screen. Is this making sense so far? Is this helping understand hows and whys? So then, once we do those two things, we have our Python scripts, which will be more towards machine learning, although not totally encompassing. And we have our script repository. And so this one is mainly R-based. So this is the script repository. But each of these are, so when you're, say, pulling up clustering, was actually in data visualization, it's running this XML script right here that includes all the options and includes all the defaults for running the clustering to an R package that spits out your results. So every time you choose a different option in the advanced analytics, it's running a different one of these or running the defaults differently within these like clustering for whatever. And I'm actually doing a really deep dive into this for 15 minutes on Thursday morning, so if you want to know about what these defaults are and how to change them, Thursday I'll be going over that. So this is hard to see, but this is opening up that clustering one, and so you can see all the different options that are listed here that you can actually change on the back end if you want to. So it flows up, and it's actually very simple for us humans. If you don't know XML or R, you can still change these and you can figure it out. But it's still located in that same script repository. You just go and change it there, save it, restart it, restart data visualization, and you'll have these updated ones. So same for the Python scripts. Here's some machine learning scripts. So if you're curious about the Python scripts that's being run in the background, because maybe you have an experience in Python, you can actually see, well, what's the logistic regression? Or also you have, like, for the machine learning, would you right-click and choose explain which we'll go into later, it goes through it does a card analysis, but basically goes into a decision tree, so you can see all the different pieces that decision tree is made of. And there's an example of what it looks like as well. By the way, these slides are going to be available afterwards, so if you can't read this very well, you can always download it, no problem. All right, so now, how are we doing? All right. For the advanced analytics options, this is where we're going to spend some of our time. We're going to go into a little bit of the statistics and the options behind the advanced analytics options to make sure that you're choosing the best options for your data. Just to reiterate, there are two main sections. There's the highlighted, and then there's the overlay and projection. And really what the cluster and outlier are just kind of it's meant to highlight or just kind of show like, hey, this one is kind of outside the normal range, or these 5 groups or these 3 groups tend to fit together, whereas the overlay and projection are going to be more math focused, like truly math focused. These are math-ish focused, whereas these have actual formulas behind them to run. So that's why they're kind of put into 2 different sections. And I honestly wouldn't be surprised if in the future Oracle added more sections as they become more common. Clusters. How many people here know the formula for a cluster, or how scientific it is? The reality is there's no science truly behind clusters. It's just kind of the computer going, kind of, here we go. So what I actually looked up behind is, well, to get to a cluster, here's the formula, if you will. You just kind of arbitrarily start with the number of groups you want. And then you estimate where the center you think of those 5 different clusters are, and then does everybody remember the y equals mx plus b from like junior high, high school? Well, that's how you figure out if it's closer to one versus the other, and then you recalculate a certain amount of times, and then you kind of go, there's your answer. But here's the funny thing, so I looked up in the back, and data visualization is doing this recalculation 20 times. So you can actually change that, but I just thought it was interesting that that was the number that they came up with. So this is not an actual science. This is more of a guesstimation that even the computer makes. So even the computer may or may not be wrong. But the key thing to this in clusters, it is susceptible to outliers. So if you have a lot of outliers in your data, or ones that can really skew, that can really skew your clusters. So just a note, so sometimes you may want to remove some of those outliers to maybe get what your true clusters of data are. And just to show in the upper right-hand corner, you have the 2 options between the k-means and the hierarchical clustering. So, let me double check something. Okay, so we have the clusters here, and this is what it normally looks like. And so, we have our data, we have our sum of metals and population. So we're doing this data mashup, and then we have the different countries listed out. So with k-means, the default here is 5 groups. And this is the default, actually. A k-means with 5 groups, and it's done by cell. So we can kind of see our 5 different groups, but we also recognize that cluster 5, those are actually probably just truly outliers. So in a real world, you may want to exclude those, but for here, this is what we have. Now for hierarchical clustering, it is no more math-based than k-means is. But does anybody have an EPM, like an S-based background? Well, people are nodding. You're going to understand this better than most because S-base and EPM are really based on hierarchies. The only thing you're doing here with hierarchical clustering is you're taking, you start with 1 to 1, so you start by grouping 2 items together into a cluster, and you get to a point where you only have 1 group left. So you can see here we have, it looks like 3 different colors that kind of come together at the end. Well, it's still not science-based, but it's kind of like grouping like items together until you get to 1. So this is hierarchical clustering. So here we can see we have about 5 or 6 for this iris data set, the size of the petals and this and that. So that I really like this picture because I think people understand hierarchical clustering really well once they see this. What we see now with this data set, when we choose hierarchical clustering here, instead of the k-means, and let me go back just so we can see it. Some of these, it's like these numbers will change just a little bit. Like now they're yellow, but in general, the clusters are pretty much the same. It just kind of figure out, it's going to group like clusters together, like items together, a little bit better than k-means. The k-means has a bit more mathematical-ish approach. So outliers, anomalies, we can all agree that this user data is not always great, but sometimes it's true. But honestly, that's when your boss comes back and say, what's going on with this, right? Spend our time figuring out what happened to the outliers. And for the outliers, I mean, to calculate them, really there's no real math identified here. It's just you're looking at your own data set going, well, that kind of looks like an outlier to me, and then you kind of, then some math comes in, because then you have to raise things highest to lowest and figure out what the fences are and the median and then why, when a tool like this can do it for you. So really, when you figure out these fences, it was really just boundaries between the quartile 1 and quartile 3. Everything outside of that is considered an outlier. So let me go back. Again, the upper right-hand corner shows the different options. So there's the multivariate, k-means, and the hierarchical clustering. So what these three calculations do, the first one actually uses a mathematical formula which is very similar to the least squares, like that y equals mx plus b, but done a whole bunch of times. And, well, I'm sorry, this is multivariate. And then, I'm going to guess it's going to be good for a lot of people, especially if you're in the EPM world and you're connecting to like an F-space cube or something. If you're using a lot of attributes or variables to separate out your data, this is going to be this is the one you should go with, because it's going to take all of those into consideration, whereas the other two are kind of, remember, they're not as solidly math-based. But if you're only using like one or two attributes, then these two may be fine. But the reason it defaults to multivariate is because it assumes that you have like 4 or 5 different attributes that you're basing these outlier things on. So again, we come back to the same data set before, and we can probably guess, because we're going to, before we actually apply the outliers, we're going to see that, yeah, the one on the top 2 and the one on the far right 2, those are the ones that are probably going to be outliers, because we're not dumb people, right? And we actually find out that the outliers that are in green are actually really anything above this line. So there are a few more outliers than we expected, but that's just the math behind it. Again, this is choosing the multivariate. I think reference lines are pretty easy to understand. I mean, people know what like average, median, and all that is. So the percentile, the key thing about this is when this percentile that you specify, it's going to say if you choose 75 percentile, it's going to set a line that includes 75% of your points. So that's the only thing to key there. And then the top end, bottom end, these are all things you can set yourself. And so the default is a line, but you can actually specify a band. And what's really neat about this, I was working with a customer that has to do with air quality, and they had a range, they had a band. And so versus them trying to say, okay, well, I want just a line, I was actually able to create a band so they could see which months were too low, which months were too high. So you got to choose what's right for your data, and you know your data better than anybody else. So you can see here, the default that's put in there, like if you choose reference line, the default is going to be your average. And so you're going to get a straight line. So we can see here, this is for the sum of metals by year by country, and I filtered out for the USA. And we can see what our average is. And then here I've sent it to 75th percentile. So this line again represents everything below that point represents 75% of the data. And then, again, the band. So if you want to do a band, and I don't remember exactly, I did it within 1 standard deviation of the mean. So I could, depending on how you want to cut your data, a lot of companies do a lot with 6 sigma data. You maybe want to do something within 6 sigma, of the mean or whatever. You can build that in here, set it up once, and be done. So trend lines. Who loves math and statistics? I think, okay, we're the only ones. We'll have a drink afterwards. I'm fine with that. So what I wanted to show here on the far right side, so this is actually our data set, and I went and actually created and did by hand math, standard deviation, and then the z-score, and then figuring out the plus or minus, all to show you that the tool is doing this already for you, so you don't have to do all that, you don't have to remember that. The default is a linear trend line, but I'm going to guess that most of you that's actually not the right thing, and I'm going to show you why you should consider some other options. So obviously we have confidence intervals, and so that's going to be built in by default, 95% confidence interval. And all that means is about that line, about the trend line, that has 95% confidence that your data points are going to fall in that line. So we can see the defaults over there. We have our trend. And again, the linear is just based off that our favorite y equals mx plus b so far. And this is only, I shouldn't say it's only useful, it's most useful if your data points didn't already follow a straight line. But how many people's data actually follows a straight line? Exactly, it does it. But that is the default. And then here it is shown. So we can see this band. So we have a 95% confidence interval. So there's confidence that 95% of the data points are going to fall in this band, but that's the actual trend line. So for the US, for the years, for the sum of metals, the trend seems to be kind of flat, which we know looking at this it's not. But then there's another option for exponential. And this is particularly helpful for when you see really sharp rises or inclines, growth in your data, or declines, so because it accounts for those sways. If you have 0 or null, it's not going to turn out correctly. So you have 0 null data, don't do it, don't choose the exponential, and like it says, provides a curved line around the data. But if we look at our data set, it doesn't really change too much, except for maybe here there's a little squiggly line because we had particularly, looks like 1928. I have my glasses on, I can't even see that. But it doesn't really change that much. But then we finally have a last one that's polynomial. And this is my favorite. I'm going to go ahead and hug the screen because I actually set this one as my default. Because how many of us actually have data that is cyclical or is seasonal, right? It has trends or whatever. This is going to be your friend because this is going to show you the actual trend. And so if you have fluctuations every so often, it's going to take this into consideration, and it's going to take those fluctuations and actually kind of balance them out a little bit. So degrees. Degrees are very important, and all degrees are is the number of peaks and valleys in your data. So if you have like a sharp incline, decline, and up, you have 3, up, down, up. That's 3 degrees. So if we're looking at this, so this data right here is the Boston Marathon finish times over the years. So the winner, what was their time over years? And this, because the Olympic data didn't work out so well, in general, we know that people have gotten faster in the Boston Marathon, right? This is not crazy, but this is showing just the linear. However, when I change it to polynomial, because I know that there's a 1, 2, 3, 4, 5, 6 kind of peaks, valleys in my data, now we actually get an actual trend versus just a straight line. And we can feel more confident about our data because even though it's not as easy to see, our confidence interval band is wider, but versus putting in a polynomial that takes into account the fluctuations, our confidence interval band is much thinner, which shows a greater accuracy. So if we look at our data, we're back to the polynomial, we can kind of see that it kind of goes up just a little bit. And so it still kind of looks the same, but that's why I like the Boston Marathon data better, because you can actually see the peaks and valleys better. Oh, and then changing, so this one I had the polynomial, but I kept it the standard 3 degrees, which is not what our data has. Our data had 4 degrees, so when we change the number of degrees, we actually see there's a sharper climb, and now we've been flat, versus what we originally had. So I encourage you to play around when you have your trend lines, you have some of these, look at the little details, because that's what it was saying versus that's what the actual trend is. So forecasting, and this is where we can get a little bit detailed, but I'm not really going to. I mean, there's really 2 options. There's ETS and then there's ARIMA. And it's a default option, but then we have, for ARIMA, then ETS, exponential time smoothing. It depends on how you want to forecast your data. So like exponential time smoothing uses weighted values. And so the values that you've most recently, like, so if we're trying to analyze what our forecast is using the past 8 quarters, it's going to weight the past like 3 quarters a lot heavier than it did, say, 5 quarters ago, whereas ARIMA is kind of going to take them all into equal consideration. So like if we were using an example, because I had heard, the day I made this slide, I heard what Coca-Cola, that their sales have been going down, and I went, But think about sales for Coca-Cola. If we wanted to see the forecast, wanted to do some forecasting for Coke, well, if we took everything into consideration, if we used, they only sold 25 their first year versus now they have 35 billion, we definitely want to use the weighted average, right? But it comes back to knowing your data. So with ETS, and I admit this is going to be a little bit harder to see, but using ETS, which is the default, we can kind of see that the forecast here goes down just a little bit. And this is using call center data that I had created for a customer prior. You see it goes down, but then the forecast is kind of flat there a little bit. But if we're using ARMA, I want to show how this works out. So if we're looking at, and I like this picture a lot that I found on the internet, so if we're kind of looking at tractor sales over the years, we can see that it does fluctuate, but that the sales go up. Well, what this math does is it kind of reduces the noise, if you will, to figure out about the mean, how much has the sales gone up and down. And then here, finally comes down to a forecast. You can forecast high, low, or middle, but this is, I'm not going any deeper than that into this, but this is how ARMA is calculated. It removes the fluctuations a little bit better. So we can see here that the decrease from the forecast is less than it was before. So that's where again, it comes back to if you have to know your data, but if you have tractor sales, if you're selling tractors, I would maybe go with the ARMA. So machine learning, this is kind of fun and this is new. So machine learning really isn't that complicated, right? It sounds cool, it's like machines doing their own thing, but it's not really that at all. All it is algorithms and formulas run in a specific order each time to figure out. So if we have, looking at the people in the room, well, how many are male and how many are female? That's the biggest one. Okay, then maybe we'll do it by hair color, by male, by female, and see how things kind of filter out, almost like a waterfall. That's all machine learning really is, but what it does do is it helps predict going on. So if somebody else walks into this room, what is their chance that they're going to be this gender and have this color hair and that color eyes? That's all it is. And so I actually chose this picture from Data Miner. It's not from data visualization, only because it shows a really good visualization on how this works out. So here we have, they start with the entire population, and we can see that certain percentages were yes and no, and then from there things filter out. That's all machine learning is. Then taking something that comes in and basing it on male, female, okay, well then they probably have this and this and this. So, and I'll show this. When you right-click on an attribute within data visualization, there's an option to explain. That's going to go through the machine learning algorithms. And because it takes longer to run, because it's running through so much, I didn't want to sit here and then, we could talk about what we want to do tonight. While it was running, decided to go ahead and pre-run it. So I did it on explain on gender for our data. So I can see that it looks like roughly 75% of our data is men, but we all know that makes sense because haven't always had as enough events for women as for men. But it even breaks down, like golf has a certain amount and then other sports. But then we start going to the key drivers. And these are hard to see, so I apologize in advance. But even like for the different sports, what are the key drivers of gender? Like, if we have gymnastics, maybe more female than men, or for men, we definitely know that for wrestling, it's been around longer, so that makes sense. But this filters out your data for you and kind of tells you what the patterns are. Then we start looking at the segments, and we can look in here and say, so this looks like 95% of gender for women with like, I think whatever that, 47% confidence, these are the sports they're going to fall in. So again, just think it's just that waterfall that's falling down. And finally, we can look at anomalies. Now what's funny here is because the Olympics has been in Athens twice, they pretty much came back and said, wait a minute, when we said Athens before, we expected this many medals, and it ended up being another set of medals. So for this data set, it didn't work as well, but it will go in and tell you the anomalies in your data from a machine standpoint. But also what's really cool about this, so if you see a visualization that you like, you don't have to try to think about the pieces that were in it. You can just click on the actual, you can choose, there are green check marks that you can choose, and you can export it out, and it'll build it for you. So there's nothing special you have to do, it'll automatically do that for you. So I had a question earlier from a previous presentation about importing scripts and visualizations. And this is not hard to do. You don't have to go find the right folder and drop it in like you used to have to do, and then it'll get wiped out every time you updated it, right? Have you done that? You know what I'm talking about? Now it's actually going to save that for you. So the process now, again, here's the link that I was referencing earlier, that if you want to go download the ones that are previously loaded, previously created, or you can create your own. It's totally cool. But there's a section, and once you hit the hamburger, to go to the console, and you can either upload your map or you can upload a custom plugin. And it's really that simple. So I imported in a dial gauge. I just picked one at random. It actually probably wasn't even the best one to pick, but I picked a random dial gauge, and it was ready for me after I restarted it. So if you have some custom plugins or see something really cool on that Oracle site that you want to use, it really is simple as just downloading and then uploading it. So let's go for the demo now. Does anybody have any questions before I switch over? Yeah?